Hello everyone, I'm Jacob Kaufman, I'm the nerd on the street, and today we are setting up TLS encryption for our SQL server. Alright everyone, so SQL, Structured Query Language, is a language that's used by some of the most popular database programs out there. MySQL, MariaDB. These are database programs that are used by some of the most popular web applications on the internet, like WordPress, Nextcloud, Drupal, MyDB, PHP PDO, Composer CMS. There are all kinds of applications that use MySQL for their databases. Now I've shown how to set up some of these web apps in previous videos, and normally it's not necessary to actually secure your MySQL server with Ssl TLS encryption. We normally set up SSL on the web server, so Apache or Nginx or whatever we're using, and that secures communications between the web server and the client, which is usually somebody's computer running a web browser where they're accessing that web application. But the actual backend communication between the front-end web server and the database server is usually happening on a single machine, at least in the configurations that I usually show on this channel. If you're running Apache and MySQL, or if you're running Nginx and MariaDB on the same physical server, or if you're running them on the same virtual private server, those applications can communicate with each other locally with Unix sockets. They don't need to send any information out onto the network, so that information doesn't need to be encrypted because it's not going anywhere. It's all staying locally on that box. However, if you're setting up a more complex environment, maybe you're expecting workloads great enough that you want to have a separate backend database server from the front-end web server, or maybe you've got several front-end web servers, maybe they're running different PHP applications or applications of any language, but they all need to access the same database server because they're all using common information. Well, in any of those cases where you're setting up your MySQL server to accept remote connections, encryption suddenly becomes very important because there's data that you're going to be sending to and receiving from that database that you probably don't want to be sent unencrypted out on the internet. It's the same stuff that we think about when we set up SSL for our website. Passwords, usually in the database, they are salted and hashed, but we still don't want those just floating around. Email addresses, maybe unpublished posts on your blog, or metadata for files on your Nextcloud server that's supposed to be private. If we're going to be sending those things between several different servers on the internet, we need to have that information between your web server and the database server encrypted, because if it's not, any queries that you're making to the database and the information that gets sent back is going to be sent in clear text, unencrypted, which means that the internet service providers in between those two servers, probably your government and possibly even people on your home or business network, will all be able to read that information very easily. So to avoid that, we want to set up TLS encryption for our SQL server. Now this is a little bit more involved than setting up TLS just for a web server. With a web server, we can normally just run certbot and it goes and gets a publicly signed certificate from a public certificate authority, and it configures everything for us when we run certbot. With SQL, we actually need to perform configuration on both the server and the client. Both of them need to have certificates to use, and there is some extra setup required to make sure that SSL is actually being used on that connection and to enforce that it's always used. So that's what I'm going to show you how to do today. I'm using a MariaDB server and client for my example. The process should be almost exactly the same if you're using a classic MySQL server. I'll put a link in the description of this video to a page with all of the commands I'm going to type in this video, so if you want to copy and paste instead of typing along, take a look in the description for that. And finally, for this video, I am assuming that you are setting this up between two Linux servers. One of them is going to be our SQL server, and the other one is going to be an SQL client, but still assuming it's a server of some kind, so not running a GUI or anything. So that's what we're doing today. Without further ado, let's cut to the desktop and get started. Alright guys, and here we are on the desktop. I'm going to go ahead and create two servers here on DigitalOcean. If you're looking for a server for yourself, I would highly recommend you go to linode.nods.co and create some Linode servers. But I happen to have a lot of credit built up on DigitalOcean, that's the only reason I'm using it. And you can go to digitalocean.nods.co to get some credit for yourself if you don't have an account there yet. Both of my servers today are going to be running Debian 10. This should work exactly the same if you're on Ubuntu. It should be very similar if you're on CentOS or Red Hat-based distributions, but I'm using Debian as an example today. And my first server is going to be in New York. I'm assigning an SSH key to it, so I don't need to use a password to log into the server. If you don't have an SSH key on your DigitalOcean account yet, you can just select the password option. And the host name for this first server, I'm going to make it example SQL server, because this is going to be where our MariaDB server is running. So I'll go ahead and create that. And while that's being created here, I'll go ahead and create our second server at the same time. So once again, Debian 10. This one is going to be in San Francisco, California. Once again, going to select our SSH key, and I'm going to make this one called Example SQL Client. So we will create that, and we'll wait for both of those to get IP addresses on DigitalOcean here. So we've got two servers here. We've got our SQL server in New York and our SQL client in California. These two servers physically are very far apart from each other. I'm kind of in the middle between them. But like I said in the introduction, if we don't set up SSL TLS for this connection between these two servers, that's going to be going all the way across the country unencrypted. So lots of opportunities for many ISPs, routers in between these two servers to be compromised by third parties. Now that both of these have IP addresses, I am going to assign domain names to both of them. I've got my DNS being managed over on Linode here, so I'm going to add example1.nerdonthestreet.com for our SQL server. And then I'll copy our client IP address, and that is going to be example2.nerdonthestreet.com. So both of these A records are in place here. I am just going to wait a couple of minutes for those to take effect. All right, and that DNS change has taken effect, so I'm going to open up a terminal here and we will connect to our first server. So I'm going to SSH into the root account at example1.nerdonthestreet.com. Once again, this is our SQL server. And the first thing we need to do, since this is a fresh server, is we need to actually set up MariaDB. So I'm going to do an apt update first. It's always good to have up-to-date package lists before we start doing anything on a server. And it looks like we do have 28 packages that can be upgraded, so I'm going to run apt full upgrade to install those. I do see that some of the packages being updated are our kernel image, Linux Image Cloud, so I am going to reboot the server after these updates are done. You can see it generating our new initial RAM disk right here. So we do want to reboot, so we're running that newer kernel version. All right, and I'm logged back in here. Now that we are up to date, we can go ahead and install MariaDB server. And just like we always do when we're setting up a MariaDB server, we also want to run the MySQL secure installation script. That's just going to run through some things. It's going to set a root password for the MariaDB server itself for us here. And then we'll just remove some default users and databases to make the server a little bit more secure. At this point, we can connect to MariaDB. We'll just run MariaDB to start out with, and I am going to create a database. If we do show databases right now here in MariaDB, you can see there are just our default databases, but I'm going to make one for us to use here for testing. So I'm going to run create database, test database, and then I'm going to create a user and grant it privileges for that particular database. So I'm going to run grant all privileges on test database, all tables, 2, and we're going to specify our new user here. So this is going to be test_user at. Now at this point, if you've done this before, if you've set up a MariaDB server before, you would probably want to write localhost here. That's what we normally do when we're setting up our MariaDB server on the same server as our web server. However, if we run this, this would specify that our test user is only allowed to log in from this particular host, from the server that we're running MariaDB on. We would not be able to connect from our external server. Since we know we're going to be connecting from a different server, I'm actually going to run this command specifying the client's IP address. That way, this user will only be allowed to connect from this particular client's IP address. You know, if people are at home or if they're on other machines, they shouldn't be allowed to connect directly to the MySQL server. They should only be connecting to the client server, and then the client server should be connecting in the backend to the server. Now, if you're going to be connecting to the MariaDB database from many different clients, or if you don't know what the client IP address is going to be, you can specify a wildcard with a % here that is less secure once again, because that means anybody can attempt to connect from any machine anywhere on the internet. So once again, I'm just going to specify that we can only connect, this user can only connect to this server from this particular client's IP address. And then we're going to, of course, add a password. So identified by, and I'll use our super secure test password here. We'll run flush privileges to apply that, and then we will quit out of the server. Now, if I run MariaDB-u test user-p right here, this should attempt to connect to MariaDB locally using this user account, and then it's going to prompt me for a password. I'm going to enter the password, and we are going to get access denied once again because we're not allowed to connect from localhost. We're only allowed to connect from the client IP address, which we're not on right now. Right now we're on the server. Now, in order to actually allow access from that server globally in MariaDB, right now the user is allowed to connect from that server, but MariaDB is not actually listening for external connections. So in order to make that happen, I'm going to just list out all of our configuration files in Ssl MySQL. And I'm doing this because I want to show you how the configuration is set up on a Debian system by default, because it's a little confusing. The standard place for MySQL configuration is at Ssl MySQL my.cnf. However, you can see that my.cnf is pointing to Ssl alternatives my.cnf. That's a symlink. If I do an ls-al on Ssl alternatives my.cnf, it's pointing back to Ssl MySQL mariadb.cnf. The reason why Debian does this is because their older MySQL package uses the same Ssl MySQL my.cnf path for its configuration. The alternatives system on Debian takes care of those situations where you've got multiple packages that provide alternative configurations or alternative files in general. Now, if we take a look inside of Ssl MySQL mariadb.cnf, if we nano into that, you can see there's not actually a lot going on in here. Basically, all that this main configuration file is doing is including two subdirectories, conf.d and mariadb.conf.d. Once again, if you were to install regular MySQL, this top one would be here and the bottom one wouldn't. So we'll exit out of that file, and I happen to already know that we need to nano into Ssl MySQL mariadb.conf.d/50-server.cnf. There aren't that many files in those two directories, so you can find that out pretty quickly if you're not watching this video, but this is the file that we want to edit here because this is where our bind address is currently set. You can see it right down here. Now, the bind address is what MariaDB is going to bind itself to. It's the address that it's going to listen on when it starts up. By default, it is set to 127.0.0.1, which is our localhost IP address. It's only going to listen on localhost. So once again, even if we give a user account permission to connect, if a user tries to connect, it's not even going to make it far enough for that permission to be relevant because the MariaDB server isn't listening for external connections at all right now. So in order to fix that, we're going to replace that with 0.0.0.0. This means that we want to bind to any network interfaces that are on the system, any IP addresses that we have. Now, if you want to, you could actually just comment out or remove the entire bind address line. There are also several other ways to accomplish listening on any IP address. We could even specify our public IP address for the server, but in this case, I do want to listen locally if I want to connect using the root user on this machine. I just also want to listen externally so that our other user can connect from the client. So we're going to set this to 0.0.0.0. We'll save that and we'll restart MariaDB so that that configuration change takes effect. All right, so now our MariaDB server is set up, pretty easy so far, and we are going to open up a new tab in console here, and I'm going to connect to our SQL client. So once again, I will do SSH root at example2.nerdonthestreet.com. It's going to ask for my SSH key, passphrase, and now we are connected. And just like we did on the server, the first thing I'm going to do is run an apt update and then an apt full upgrade, just making sure that our server is up to date when we start the process here. And once again, since our kernel has been updated, I am just going to reboot that server before we start so that we're running that updated kernel. Okay, and on this server, we're not going to install MariaDB server. Instead, we are going to install MariaDB client. Now, the MariaDB client core gets installed by default as a dependency when we install MariaDB server, so you don't normally see me explicitly installing this client package in my videos, but in this case, I am installing it since the purpose of this machine is just to be a MariaDB client. Okay, and at this point, we can connect to our database. We're going to run mariadb-u testuser-p --host equals example1.nerdonthestreet.com. So our client is going to connect to our server right now. It's going to ask for our password. And when I run that, you can see we are connected. Once again, we know we're connected to our remote database because I didn't install the MariaDB server on this machine that we're on. I only installed the client. But I can run show databases. And you can see we've got our test database right there. You can see I've got less here in this database list than I did on the other machine because there are some system databases that the root user has access to that our other user obviously won't have access to by default. But that test database that I made on the other machine, since we gave this user full access to it, we can see it listed here. Now I'm going to go into our test database. And I am going to just put some data in here that we have to test with. Now, once again, right now, everything that I'm doing, these commands that I am typing, they are being transmitted across the entire continental United States, unencrypted from this client to the server. But with that in mind, I am going to take a look here. If I do show tables, there's nothing in this database yet. So let's create a table. We'll call it test table. And that test table is going to have two fields in it, two columns. We're going to have record ID, and that will be an integer, and we'll have record text, and that's going to be a long text data type. So I'll run that, and then I'm going to insert some data into that table. So we're going to run insert into test table values, and we'll make the first one, we'll give it an ID of 0, and we'll say this is my first record, and then we'll do that again, but we'll give it an ID of 1, and we'll say this is my second record. All right, and we will select all from our test table just to see that information that we just inserted. And you can see we've got record ID 0, first record, and record ID 1 is our second record. Now, just to drive the point home that we just did that without using SSL, I'm going to run show variables like, and we are going to do a wildcard, SSL, another wildcard. And you can see these are our system variables for SSL. And this is actually going to be server-side settings that we're viewing when we're looking at these variables. So you can see our server, it's not compiled with OpenSSL. That's not going to change by the end of this video. Have OpenSSL has to do with how this was compiled. We're using the Debian package for MariaDB, which is compiled with YaSSL instead of OpenSSL. But you can see here have SSL is set to disabled, and we don't have an SSL cipher set up here. We don't have any certificates or keys configured. So those are the server settings once again. And then on the client side, if I do status, this is going to show us information about our connection that we're using right now. And you can see SSL once again says not in use. So we know that everything we just did was sent in plain text. Now I'm going to run quit. And at this point, I am going to do one more thing here. Normally, when you're using MySQL, most people don't use it on the command line. It's very helpful to be able to know how to use it on the command line, how to insert records, view records, modify records. Very helpful to know how to do when troubleshooting and supporting a web application. However, most people are actually going to be using this with web applications. Maybe you're using an off-the-shelf app like WordPress or Nextcloud or Composer, or maybe you're writing your own. So I'm just going to write a really simple PHP file that is going to connect to this database and basically just print out all the information in this table so that you can see what this looks like from a couple different perspectives in terms of usage. So I'm going to run apt install PHP since we are going to be making a PHP file that will require the PHP program to run. And I'm going to nano into a file. This is a new file called readrecords.php. And inside of here, I am going to, once again, like I said, I'm just going to write a really simple PHP file. So I'm going to start off by putting ourselves in a try-catch structure here. And what we're going to catch is PDO exception. So in this example file, I'm going to be using something called PDO. It stands for PHP Data Objects. And it is one of the two main ways that you can connect to SQL in a PHP application that you're writing. Now, the other main way would be the MySQL I plugin for PHP, which is the MySQL improved plugin. I prefer to use PDO because theoretically, if you ever need to change the type of database that you're connecting to, PDO doesn't just support MySQL, it supports other database types as well. So if you use PDO, you'll have to make less changes to your application than if you use a MySQL specific PHP module. So all I'm really saying here is if we get a PDO exception, if our PHP data object has an error, we want to catch that error and we want to echo it out onto the terminal so we can see it. I'm going to set up what our connection is going to be. That's going to be a new PHP data object, and that PHP data object is going to be MySQL host equals example1.nerdonthestreet.com. Our DB name, database name, is test database. And that's the first argument for our PDO object here. The second argument is going to be test user, and then our third one is going to be password, which is obviously the password we're using to connect. Next, I'm going to go ahead and set an attribute on that connection object. That attribute is going to be PDO attribute error mode. We are going to set that to error mode exception. And the reason I'm doing that is because by default, PDO is going to just silently fail if it has errors. We don't want it to silently fail. We do want it to throw an exception because we already wrote the bit below here that's going to catch the exception and echo it out. Now, after we establish the connection there, I'm just going to echo out connected to SQL and then a new line. That way we know whether we connected successfully when we're testing this later. And then I'm going to echo out SSL cipher info. And the SSL cipher info that we are going to dump is going to be the exact same thing that we just looked at in the MariaDB command line. We're going to run var dump connection query show status like. And I'm not going to do everything with SSL. I'm just going to do SSL cipher fetch all. And so that's going to just be dumped out and echoed onto our command line. Then I'm going to echo database records. New line. We're going to write a statement here. So on our connection, we are going to query select all from test table. Once again, just like we did on the command line a moment ago. And then we are going to execute that statement. We don't need to prepare it since there are no variables or anything. It's just a simple query. It's already written the way it needs to be executed. So we will execute. And then with the results, I'll say while row equals statement fetch. We're going to echo out the record ID for each row, and then a space, and then we're going to echo out the record text for each row, and then a new line in between every row. And that's our file. So very simple little PHP application that is just going to connect to a hard-coded SQL server and run a hard-coded query or two. Now, if I run this right now, I'm going to run php readrecords.php. It's actually going to give us an error, and this is exactly why I put that try catch statement in there. You saw me write error : space, and that's where this is coming from. And then we've got the actual exception from PDO, could not find driver. I installed PHP on this server. I did not install the PHP MySQL plugin yet. So I'm going to install PHP MySQL. And once that's installed, we can run this PHP file again. And it looks like I made a typo in my query. That needs to be show status, not slow status. Try that once again, and this is what I was expecting this time. You can see we connected to SQL successfully. We've got our SSL cipher info, and that cipher is empty. There are cipher variables present, but there is nothing inside of those variables because we're not connected over SSL. And then down here, we've got our database records. So we are successfully reading from our database. That much is working. But once again, this was sent unencrypted over the internet. So we're in a good place because the functionality itself is working. We just need to secure it and hope that we don't break the functionality in the process of securing it. So to do that, we're going to hop back over to our SQL server and we're going to generate some Ssl certificates and keys. Now to do this, I'm going to make a directory in etc MySQL. It's just going to be etc MySQL SSL. You can do this wherever you want. I would recommend if you're generating certificates and keys specifically for MySQL, you keep them with your MySQL configuration files. I'm going to cd in there real quick. I do want to say though, it is possible if you want to actually use a public certificate authority like Let's Encrypt, for instance, you can do that and you can use the Let's Encrypt certificate authority cert and you can use your public cert and private key that you get from Let's Encrypt with MariaDB. What I'm going to show you how to do here is we're going to actually be our own certificate authority. The reason why Let's Encrypt has to exist and why it's so important is because when people connect to your website with a web browser, where'd my DigitalOcean go here? My web browser here is just from my operating system. I installed Arch Linux and I installed the Brave web browser. Brave is based on Chromium and there's a set of trusted certificate authorities that is built into Brave here. If I take a look at the certificate for DigitalOcean, for example, this is a DigitalOcean that was issued by Cloudflare, very big company on the internet, and they are a root certificate authority that is trusted by Brave. When you're setting up a front-end website and you're setting up SSL TLS for your front-end website, you need to have your SSL certificate be signed by a public certificate authority. If you try to self-sign a public-facing SSL certificate, what's going to happen is people accessing your website are going to get warnings on their web browser that this website, even though it is being accessed over an encrypted connection, the certificate was not signed by a certificate authority, which means that some sort of attack could be taking place. So that's necessary because when you're setting up a website, you don't have access to all the people's computers who are going to be going to your website. You want it to just work for them automatically. You don't want to have to install your certificate authority on their computers. In this case, though, we control both ends of the connection. We control the server and we also control the client. So I am going to show you how to be your own certificate authority here, just because that way you don't have to send any information at all to Let's Encrypt or whatever other certificate authority you might be using. There's no reason to really do that and put that strain on their infrastructure. Like I said, you could do that, but in our example here, we're going to use OpenSSL on the command line to do this. A large enterprise organization might actually have a separate third server that is just being the certificate authority for that organization, and that server's job might just be to generate certificates all day, every day. That's all that server does, is it handles the certificates for the organization. It's not necessarily the best practice to have your certificate authority also be one of the servers that's using that certificate authority, but in this case, since we're just using this certificate authority for MySQL, it's more than sufficient for the security we're looking to set up. So I'm going to run OpenSSL gen pkey, that's generate private key. We're going to use the algorithm RSA private key opt, so our options, RSA keygen bits, we are going to use a 4096-bit key, and we are going to output that to cakey.pem, so that's certificate authority key.pem. So we've got that now, and next I'm going to run OpenSSL rec, this is request, a new certificate, -x509, that's the certificate standard that SSL TLS uses. No DES, this is going to not encrypt our certificate. If we encrypted their certificate, the certificate would require a password to use. We don't want to have to type a password in every time we try and use this certificate, so we're specifying no DES encryption. That's also the default when you're setting up a public web server. We're going to specify the number of days this is valid for, and I'm going to specify 365 days, so this certificate is not going to expire for an entire year. This is in contrast to Let's Encrypt, where your certificate is going to expire after 90 days. Let's Encrypt does that because they want to encourage people to set up automated renewals for their certificates, which is a good thing to do. And even if you're being your own certificate authority like this, it would be a good thing for you to set up automated renewals, automated regenerations of these keys using scripts. You know, I've done a video about how to make systemd timers that might be useful for this sort of thing. Because right now, if I just generate this for 365 days, this is going to work great for a year, and then it will break until I come back and manually fix it. You don't want to have to manually fix it every year. You want to set up a systemd timer or a cron job or something else that is going to automatically regenerate these keys and then copy some of them over to the client. If you really want to, you can just specify an absurdly high number of days here so that this will last for 100 years or 500 years or however long you want it to. The downside to doing that is if your key is compromised, especially if you don't know about it, then people will just be able to use that compromised key to read your communications that you thought were secured. It's just a good practice to at least specify some human time frame in which this certificate will be automatically or manually recreated. So we're going to specify the key we want to use to create this certificate is our certificate authority key. We are going to output this to certificate authority cert.pem, and then I'm going to put a subject line here. Now the subject line is optional. If you don't run this, it's going to actually prompt you. It will walk you through in a sort of tutorial all of the different pieces of information you need to provide. The reason I'm showing you how to do this on the command line with a single line command using the subject option, once again, is because if you script this out, if you put this in a cron job or a systemd timer, your script can't interact with that prompt, or it would be much more difficult to make it interact with the prompt. So we're just going to use the subject line. We'll say our country is the United States. Our state, I'm going to put Missouri, and our locality, I'm going to put St. Louis. That's not actually where I am, but I like St. Louis better than Denver, so I'm going to pretend that I'm in St. Louis. Our organization is Nerd on the Street Productions, LLC. And then our common name is going to be Knots CA. So the common name here, we have to make sure this is different for all three of our certificates and keys that we're generating. So we're going to have one certificate and key for the certificate authority, one certificate and key for the server, and one certificate and key for the client. For the server and client, I'm actually going to use domain names here. You don't have to use domain names. You can make the common name whatever you want, but you do have to make sure that those are different. If the server and the client have common names that match, they are going to get confused later and they'll throw error messages at you. So at this point, we now have our certificate that we just created using the key, and those are both for our certificate authority. So now, like I said, we need to create a key and certificate for our server. So to do that, we'll run openSSL request new key RSA 4096 no DES key out. So we're going to output our key to server key.pim, and then we are also going to output a request for our certificate that is going to be server request.pim, and we'll make our subject here once again country equals US, state Missouri, locality St. Louis, organization Nerd on the Street Productions LLC, common name. So this is where I'll put example1.nerdonthestreet.com, since the key and certificate requests that we're creating right now are for our server. So I'll run that. It's going to generate a private key for our server, and we can see that that is here. We also have a request for a certificate. So this is not actually a certificate yet, but if we take a look inside of there, you can see it's a certificate request. We need to send that request to the certificate authority, and it will give us an actual certificate back. To do that, we'll run openSSL x509 request, input our server request, days 365, certificate authority, ca cert.pim, certificate authority key that we're going to sign this with, ca key.pim. We're going to specify ca create serial. So every certificate needs to have a serial number with it. We don't actually need to use the serial number for anything, so we could just specify a random serial number ourselves, but this is going to generate a random one for us. And we'll output this certificate to server cert.pim. And so that has been created, and we now have server cert.pim, you can see right there. We're going to do the same thing for our client. I'm just going to paste this command in, but it's the exact same command that we just ran for the server. The only thing that's different is the common name for our client is now going to be example2.nerdonthestreet.com, and we're naming these files client key and client request. We'll run that. It's going to generate another private key, and then once again, we are going to send that request to our certificate authority, which is ourself, to get an actual public certificate that we can share. So at this point, if we take a look at all the files in this directory, we are now a functioning certificate authority who has issued several certificates to ourself. And just to make sure that that expiration date that we set took effect, because that's kind of an important thing, the default is 30 days if you don't specify anything. So the difference between 1 month and 12 months in terms of how often you have to service this thing is quite a large difference. We're going to run openSSL x509, end date, no out, input ca cert.pim. So our certificate authority certificate is going to be valid until January 10th, 2022. It says it's valid not after January 10th, 2022, which is a year from right now. We'll do the same thing for our server cert and also for our client cert. And you can see all three of those are good to go until January 10th, 2022. There is one more thing we have to do. If we take a look inside of our server key.pim, if this was a real server, I would never be showing you this, but this is the actual private key for this server. So if somebody has this private key, this is what they need to decrypt the communication. So anybody with this private key can see what we're saying, even when it's encrypted. Now you can see at the top of the file here, it says begin private key. You might have also noticed earlier, I used the openSSL genp key command, which is the latest and greatest way to generate private keys using openSSL. However, MariaDB in particular does not work with these private keys as generated by OpenSSL. It needs an RSA key, and our private key is in RSA format, but the default format that it uses, it puts that RSA key in there, and then it's also got a little bit of metadata at the end. And MariaDB doesn't care about that metadata, and it doesn't know how to handle it. So MariaDB would give us an error message, or actually it wouldn't, it would just not work if we tried to use it with this server key. So we need to convert this server key.pim into a plain old RSA key. Like I said, same key, just without some of the metadata. And in order to do that, we're going to run OpenSSL RSA. We're going to input server key.pim, and we are going to output server key RSA.pim. So this is going to write an RSA key. So if we nano into server key RSA, you can see at the top it says begin RSA private key. This is what you need to have at the top of the file that you're using with MariaDB. All right, and if we do an ls-al to take a look at our permissions here, the very last thing we need to do is just change one little permission. MariaDB is running as the MySQL user. Now you can see that the directory that we're in, etc MySQL SSL, that directory does give read and execute permissions to all users on the system. All of our certificates also have read access for everyone because certificates are generally public information. You can share those and it doesn't breach any security to share your certificate. The key, that's private. That's why we called it a private key. So by default, the only person who has permission to read the key is the owner of that file, which is root. So we're going to just change ownership to MySQL. We'll use the MySQL user and then also the MySQL group. We're going to run that on server key RSA.pim just because RSA.pim is the one that we're going to be putting into the MariaDB configuration. And it's a better idea to do that. If you want to, you could alternatively just give others read access to the server key RSA.pim file. But then if you've got other users on your system, if a different user on the system becomes compromised, they could read your private key and once again, decrypt your communications. So it's a better idea since this particular file is only ever going to be used by MariaDB. We'll just give MySQL ownership over that file. It is something that you have to script though if you are making a systemd timer to remake these certs every year. Make sure that you include changing the permission of that file. So that's everything we need to do for setting up our certificates. That was a little bit more work than you might expect if you're doing something like Let's Encrypt. On the other hand, we didn't have to prove to anybody that we have control of this server. We didn't have to have any external communications. We generated all of that ourselves, which is kind of cool. So now we are going to set up MariaDB to serve over SSL TLS because right now it's not configured to do so. So if I nano into, once again, this is our etc MySQL directory, I'm going to nano into mariadb.conf.d/50-server.cnf. And this is the configuration file that in Debian by default is going to allow us to configure SSL. There are other places we could put it, but we've got the examples here, so we'll use those examples because it's less typing. So we've got SSL CA, SSL Cert, and SSL Key. So our certificate authority, that is going to be the public certificate for our SSL certificate authority. So that's etc MySQL SSL CA cert.pim. And then our SSL cert was at etc MySQL SSL server cert.pim. And then we've got our SSL key, that was etc MySQL SSL server key-rsa.pim. We are also going to come down here to the SSL equals on. Now, if you take a look at these comments, it says we can accept only connections using the latest and most secure TLS protocol version. That's a little misleading. MySQL is still going to accept non-encrypted connections as well. It's talking about if you've got TLS, if you're connecting, if your client supports TLS, you can restrict it to say, I'm not going to use SSL 1.0 or 2.0. I'm only going to use TLS version 1.2 or higher. However, that only works if you're running MariaDB compiled with OpenSSL, which ours is not. We're running on Debian, which is going to compile with YaSSL. We saw that earlier in our MariaDB server output. We're just going to turn SSL on here. However, on isn't the correct syntax. If you actually try and start it with this, the server will start, but you won't actually have SSL enabled. And if you take a look closely in your logs, you might notice, or you might not, since it's such a small error message, that SSL equals on is not a recognized option. SSL is a Boolean configuration option in MariaDB, and it only accepts true or false, so we're going to change that to true. If you set it to on, it's going to default to false. So these are things you learn while watching Nerd on the Street videos. I have dug through all the logs so that you don't have to. So we'll save that file and we will restart MariaDB. And it has restarted. We are going to connect MariaDB-u root-p. I'll type in our MariaDB server's root password. And at this point, I'm going to show variables like wildcard SSL. So let's take a look at what SSL configuration we have going on now. As you can see, have SSL, this is set to yes. Once again, you can ignore the have open SSL. This was a compilation option that was not set. There's nothing we can do about that unless we want to recompile MariaDB from scratch. But we do have SSL enabled now. Have SSL, yes, that's what you want to be looking for. Even if you see the rest of this configured, if have SSL is set to no, you've got a problem somewhere. Permissions issue, configuration issue. If this is set to no, your MariaDB server is not going to be using SSL under any circumstance. But we have SSL set to yes. That means that we are configured properly, and this server is ready to accept connections over SSL. You can see we've got our certificate authority, our SSL cert, our SSL key here. Once again, we didn't specify any particular ciphers or anything more complex. This is going to encrypt our communications at the very least, though. I'm going to quit out of that. And now that our server is ready to accept SSL communication, we're going to come back over to our client and set our client up to access the server over SSL TLS. Now, once again, I'm going to make a directory at etc MySQL SSL. And I am at this point going to open up a file browser on my local computer. We need to copy a couple of files from our server to our client. Since we used SSH keys for authentication, there's no password on my root user on this server or on this server, so it would be a little tricky for me to use SFTP or anything like that to copy the files directly from one computer to the other. So I'm just going to use my own computer here as a intermediary. If you're on Windows or Mac OS, you can use a program like FileZilla. But I'm going to run SFTP. I'm going to connect root at example1.nerdonthestreet.com/etc MySQL SSL. And that is going to connect there. I am also going to connect to the same directory on our client. So example2.nerdonthestreet.com. And we just made that directory so it's empty. So the only files we need to copy are cert.pym. Once again, we don't want to copy the certificate authority key. That's private, and that should stay on the server that's generating the keys. But our cert.pym, that's what's going to allow our client to trust the certificates generated by this authority. So we'll copy that one. We also need client cert.pym and client key.pym since we generated those specifically for this client machine. So I'll just copy those over with a Control-V there. I'll close out of our file browsers. If I do an ls in etc MySQL SSL, you can see we have all three of those files. I'm actually going to cd into etc MySQL SSL, and I am going to run the same command that we did on the other machine to convert this key into key RSA. Once again, it's a modern key with a little bit more metadata right now. We need to strip that out and leave a plain RSA key. So we are going to input our client key and output our client key RSA.pym. Okay, and we'll nano into etc MySQL mariadb.conf.d/50 client.cnf this time instead of server. Since this is our client, we want to come into here, and we'll come down here. We are going to uncomment our SSL cert and key. We do want to also add on top an SSL CA option. And the CA option is going to be etc MySQL SSL CA cert.pym. We'll have etc MySQL SSL client cert and MySQL SSL client key RSA.pym. Once again, because even the client for MariaDB doesn't know how to read a regular private key, it needs to be an RSA format private key. Down here, allow only TLS encrypted connections. We want to turn that on, so SSL verify server cert equals on. This is also going to check our server's certificate that it sends us against our certificate authority. So we've got our client certificate here. When we attempt to connect, we're actually going to send this client cert to the server, and the server is going to send the server cert to the client. It's not going to send the server key, but it will send the server cert to the client. So the client is going to verify that server certificate by checking it against the certificate authority's certificate, since, as you might recall, when we set this whole thing up, the first thing we did was we made the server key and the server cert because it signed the rest of the keys and certs for us. So we will save that. And at this point, we are going to run MariaDB-u test user-p host equals example1.nerdonthestreet.com. It's going to ask for a password, and we are connected. And if we run status here, you can see SSL cipher in use is, and we've got our cipher that we're using right there. If you see SSL cipher in use under your status, you are using an encrypted connection. Do not be confused if you run that show variables like option again. You'll see there's no cipher specified here because we're not forcing any particular cipher. What you want to look at on your client is the status, because this is talking about the actual connection we are using right now. So it did automatically determine a cipher that is supported by both the client and the server. So at this point, if we do anything, if we insert records, if we show records from our database, all of that is going to be encrypted now. So it's secure. None of the people in between those two servers on the network level can see what's happening other than some data being transferred. Now that's really great. However, if we quit out of this SQL connection and we go back into our configuration file, if we comment out all of that SSL configuration, we'll save that. We can connect again. And we are connected, and if I run status, you can see, once again, there is no SSL. SSL is optional right now. So if anything happens, if those certificates expire, or if somebody deletes one of those certificates from our client or from the server, if anything happens that makes SSL unable to be used, this will fall back right now to a plain old clear text connection. That can be useful in some cases. In other cases, you might want to avoid that. If you want to be sure that you're always secure and you're not sending any sensitive data between these two servers unencrypted, you want to force SSL all the time. So we're going to do that by forcing SSL for the user that we're connecting with. Since we know we have this user, anybody connecting to this server needs to be connecting with a specific user, and this user is the only user that's allowed to connect from this IP address of this client. The way that MariaDB handles forcing SSL is on a per user basis. So we're going to come back over to our server here, and we're going to run MariaDB-u root-p. We'll enter in our MariaDB root password again. Now I'm going to run show grants for test user at, and I'm going to put in our IP address, which I don't remember off the top of my head. So I'll go ahead and copy that from our DigitalOcean page here. So show grants for test user at this IP address. And this is going to show us what permissions we have set up for this user. If we just do show grants for test user, it's going to default to a wildcard, and it will say we don't have any grants defined for the user, test user, for any host. So we do need to specify what host we are allowing it to connect from. When we're on this IP address, this particular user is able to do anything on test database. We've got grant all privileges on test database to test user. So that's the data manipulation portion of our permissions. But above that, you can see we've got grant usage on anything. So we've got grant usage on our entire server to test user identified by password. So we typed in a single command for both of these things. We typed in grant all privileges on test database to test user identified by, and we put our password in. When we ran that command, MariaDB actually split it out into two different lines of configuration for us because the connection information is separated from the actual privileges to read and write data. So this first one is what we want to modify, and I'm going to run grant usage on, once again, everything to test user at 159.65.98.46, require SSL. Now, since we're running grant usage, we're not running grant privileges, this is not actually going to change what this user is allowed to do once it's connected. This is just changing how we're allowed to connect. And if we do our show grants command again, you can see that require SSL is now appended onto that grant usage line. So we're going to quit out of MariaDB now, and we'll come back over to our client. I'm going to attempt to connect, and this time we're going to get access denied since we updated that rule and we said we need to connect using SSL. SSL is still commented out in our configuration file on the client, so even though we entered the correct password, we got access denied. So I'm going to nano into our config one more time. We will uncomment our SSL configuration. And if I connect now, you can see we are connected. And if I do a status, the reason why we were allowed to connect is because we do have SSL enabled. So that's great. And then the last piece of the puzzle here is if we go back into our home directory, our PHP file, the way that you're probably going to be accessing MySQL through some sort of application. Maybe it's not PHP, maybe it's Java, maybe it's Python, maybe it's something else. In my case, it's PHP, and if we run that PHP file, we're going to get the same error, access denied, because that PHP file has not been configured to use SSL yet. So we're going to nano into this PHP file and set it up to use SSL. So how do you do this with PDO? It is going to look different if you're using MySQLi, but for PDO, since that's what I'm using in my example, we're going to create an array here, PDO options equals, and this array is going to contain the same three things that we had to configure in our MariaDB client configuration file. So we'll say PDO, MySQL, attribute, SSL, certificate authority. That is going to be set to etc MySQL SSL ca cert.pem. PDO MySQL attribute SSL cert. That is going to be set to etc MySQL SSL client cert.pem. And finally, PDO MySQL attribute SSL key. Now for this one, I'm actually going to use something different than what I used in the configuration file. PDO, it's more modern than MariaDB is in terms of what it supports with SSL. And MariaDB is actually being updated as we speak. There are some things when I was researching for this video, there are some options for the configuration file that are in newer versions of MariaDB that have already been published. They're just not in Debian yet because Debian, like most server-grade distributions, tends to lag behind a little bit in terms of its feature updates. But the version of MariaDB we have right now, it needed us to convert that key into a plain old RSA format. PDO doesn't need us to do that. PDO can read the default OpenSSL format for that private key. So if we add etc MySQL SSL client key.pem, that is going to work. Now for all three of these files, they do need to be readable by PHP. In my case, since I'm running this on the command line, it's going to be using my permissions and I'm logged in as the root user. If you're making an application that's running with Apache, then you probably need to assign this client key file. You need to make it so that the Apache or www data user owns that file if it's not readable by everyone on the system. But we've got an array with those three options, and down here in our connection, we've got the connection itself that we're creating. We've got our username and password, and then we're going to add one last thing in here in this PHP data object. That is going to be our PDO options array that we're passing in. So we'll save that and we'll run this one more time. We've got an unexpected, let's see. I forgot to put a semicolon down here after this closing square bracket for our array. My videos are very realistic. They include the typos that you make while programming. So we are going to run PHP, line 4. I need commas in between these array items as well. And I can even put a comma on the last item there and it's not going to get mad at that. Now we can run our PHP file once again, and you can see we now have an SSL cipher. So we have verified, well, for one thing, we knew that we weren't going to be able to access this server anymore without SSL, but now we can also see in our output that our PHP PDO setup is using SSL. It's got a cipher there, and we are able to read our records. So that's it. That is how to set up your SQL server to serve over SSL TLS, and that's how to implement your client accessing it over SSL TLS both for command line usage and for real world application usage. I hope this was helpful to you guys. It was surprising how difficult it was to find information on this particular topic when I was trying to set this up for one of my projects. And it is something that is relevant for a variety of different things that you might be doing. So hopefully this was useful to somebody out there. If it was, feel free to join the Nerd Club at nerdclub.knots.co. It's just $3 a month, and you can help me make more cool tech videos like this one. For now, though, that's everything I had to show you. So I'm Jacob Kaufman. I'm the nerd on the street, and I'll see you guys in the next one. Bye.